Hello, welcome back to More Fun Fixing It. I'm glad you're still here after the last episode. Let's call it an episode, not a debacle. I think I've learned a lot of lessons from the repair that I made on that last video, on that C64 with the dodgy reset line. And I won't be making quite so many mistakes this time. I'm not going to count them out altogether though. Anyway, we've got another C64 out of that batch on the bench, and this one, blue screen, needs clips. So the case clips are broken on this one, but it's a nice case. It's in quite good condition. It's worth fixing the clips on this one, as long as the the screw posts are okay. And I've written on here from the triage episode, bad CIA question mark. Oh, okay. So we've got that one, the internal part of that screw post is gone. That can be glued back, actually. That's not too bad. This one is cracked, so I'll probably run some super glue into there and put some heat shrink tubing around it to support it. But this one is snapped off, but it is still here with the screw. So I'll leave that there for now, and I'll glue it back, put some heat shrink tubing around that one as well. But yeah, this also needs its case clips done. So quite a lot of work to do on this case. So this one, yeah, I don't like fixing cases. I like fixing silicon and other bits and wires and things. Right, so I've written bad CIA on this one with a question mark, and I've even put a question mark on this CIA. And the reason that I say that is because in the triage episode, I realized that the CIA that in this socket has obviously been changed. And it is a later date. It's much later date. This one is 1984. Actually, yeah, I thought it was later than that, but the CPU is 1989, 18th week of 89. The other things that I didn't realize that I hadn't noticed at the time is that all of the ROMs, these two ROMs, the kernel and the basic ROM, have had their 24th pin chopped and then resoldered. So that must have been part of the diagnosis to find out that the CIA was bad on this one, and then they socketed it, thank you, whoever the previous repairer was, and put a new 6526 in. My instinct is immediately to look at the old the other CIA, because if this one's gone wrong, then there's a good chance that this one's gone wrong. And now that could be based on absolutely nothing but gut instinct, and sometimes that can serve you well, but you should also do all of your research and check in everything else. The other things I've done, I've obviously taken that CIA out and tried and tested that one in the triage episode, and that's okay. I've also removed the PLA, which is in a socket. The SID is not in a socket. This one's quite easy to get confused. So I've checked the PLA and the CPU in a working machine, and they are both good. I've not checked these multiplexers yet, but we'll get to that if we need to. I want to focus on the CIA first, and I want to show you what I actually found, because I've done a little bit of initial work on this. But let's go through the first steps of what you should do when you are diagnosing the problem with a C64. And once you've inspected inside, I would say, as long as there's nothing that looks really bad, like an exploded capacitor down here or a voltage regulator with a big chunk missing out of it, as long as nothing like that looks really jumps out and says to you, oh, there's something electronically wrong with this, then it's safe to turn on a C64. Obviously, you know, take precautions, but this is what happens when I turn on this C64. I get a blue screen. Can I just hold the video up here for a second and explain something that might be apparent to some people but not to others? And that is, on this screen that you can see now, there is actually some text showing, and I could not see that. I couldn't see that on the screen that I used on my bench or on the capture. And so I had no idea that the computer was actually running, which is kind of important. And if I'd seen that, this whole video would have been a very different affair. Carry on. It kind of went purple for a second then, and then blue. And I don't think it's running. So we've definitely got some voltages going in, but it's worth checking all of the voltages are there, because they don't all come from the same place. The 5 volts for all of the chips on this side of the board, everything over here, all, apart from the SID, all come from the power supply itself. Straight from there's a 5-volt voltage regulator in the power supply that provides 5 volts to everything on the board. The VIC-II and the SID both require their own 5-volt supply, and that comes from this 5-volt regulator here. But there's also a 12-volt regulator here that does some other stuff, and it feeds. I can't remember whether it's 12 or I think it's 12 volts on the SID and the. Is it both of them? I need to check this. Sorry, yeah. So I was right. There's 12 volts on the SID2, on the VIC-II, and on the SID, and there's also 9 volts goes to the modulator. There's AC goes out to the edge connector, as well as 5 volts. So there's a big old mishmash of voltages to check. And the way that I always check this is I put my meter onto DC to start with, and check that there is 5 volts on the output of the 5-volt regulator, and there is. And then that there's 12 volts on the output of the 12-volt regulator, and there is. And then the other thing to do is to pick a random logic chip and check between. I've got the leads the wrong way around. Between pin 8 and pin 14, or the 2 corners. Sometimes it's a 16-pin chip, and sometimes it's a 14-pin chip. But the 2 corners, the last one on this side and the last one at the top on this side, and you should get 5 volts. That's good. And then there should be 5 volts here on the edge connector being passed out, and then there should be like 10 volts on here on the edge connector. So you're looking for the gaps. The gap on this side is 5 volts, and the gap on this side is the AC, and it's a little low, but that's fine. So we've got all the voltages. Okay, and I've got my oscilloscope set up over here for the next stage of what we're going to check. And the first thing to do is grab one probe, and I want to check on the CPU for the clock and a reset. So the first thing I'm going to check for is the clock, which is on pin 1. That's the clock input. And then the clock output from the CPU is pin 39. And there's slightly different amplitudes, or peak to peak. But I think that's some internal processing on the CPU that does that. And then the reset line should be high. It's very, very, very noisy. I don't know why that is on this one, but I'm going to turn it off. So that should start low, and I'm going to go 3, 2, 1, on, and then high. So there's that 1 second pause, or probably less than 1 second, and then it goes high. So we've got a good reset this time. And you don't want the reset signal to go immediately high, because that is not a valid reset signal, and it won't work. So the next thing for me to do at this stage is to focus down on what might be the problem, what I suspect is the problem. So you use your best information that you've got available to you, and for me at this stage it is, could it be this CIA, this 6526, because this one has been replaced in the past, so therefore this one could have gone faulty as well. And there isn't very much scoping around on this CIA. There really isn't very much. There's stuff going on that actually looks very, very normal. Especially down the right hand side. There's more activity on the right hand side of the CIA from pins 21 to 40. There's lots of this sort of thing going on, and all of that is very normal. And a really good resource that you've got available to you when you're checking CIAs is there's one right next to the other, and they are both pretty much do or display the same sorts of signals. They don't do exactly the same things, because otherwise why would there be 2 of them? But they are very similar enough that you can spot problems by going from one to the other. Okay, so but down this left hand side, so if I start at pin 1, pin 2, pin 3, it's not doing, it's 5 volts high. Pin 4 is 5 volts. Pin 6 is ground, or is low. Pin 7 is 5 volts high. Pin 8 is low. Pin 9. Hang on. 1, 2, 3, 4, 7, 8, 9. And now that one, oops, I slipped off. I think that's pin 9. I might have miscounted some of the other ones. But that one's saying 2 point, well, there's 240 millivolts of noise there. But so 2.2 volts, that's sitting at 2.2 volts. And that's not right. If I go to the other CIA, 1, 2, 3, 4, 5, 6, 7, 8, 9, same pin on that one is sitting low. If I grab my test C64 and stick the probe on this one, and we have a look down here, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 5 volts high. That's what that should be. And 1, 2, 3, 4, 5, 6, 7, 8, 9. The other pin, the 9th pin on the CIA1 or U1 is low. So that is one of the big differences between these two chips, and which would make things difficult to spot. But the thing that stood out to me here is that it's at 2 volts, and 2 volts is not a high or a low, it's floating. That's bad. But why is it bad? So if you look at the schematic, CIA2 is down here and pin 9 is PA7, and it's a really bad print here, but it does say data there. And if you follow the line out, it goes to a cross point here, and it goes through some resistors and to 5 volts and all sorts of bits and pieces, but it goes up, all the way up here, and all the way out to the serial port at pin 5 on the on the serial port, and that's the data port on the serial bus. So it's expecting that to be high. That should be, by these resistors here on 5 volts, that should be pulled high, and if it's getting data, then the data will pull it low to signify data coming over, and it's somewhere in between. So there's either problem in the CIA itself or the pull-up resistor, but it also comes back, if you follow the line, there's a point where it comes back into U8, which we've had some problems with in the very recent history as well. That could be pulling it low, and that's pin 2 of the 7406. So we've got a few suspects. There's some passives here, a diode, a resistor over here, and the 7406, the CIA at U2 or the passives. I'm going to say my initial thought and feeling is that it's the CIA. And a really good way I can check this and test it is to pop this board out, desolder just that pin, and then disconnect it from the board. So make sure there's no solder and it's not touching anything in the via, and then test the pad to see if that's got 5 volts. If that's gone up to 5 volts rather than hanging at 2 volts, then it's the CIA. If it's still in the same place, then it's something on the board, probably, or gone down to ground. It's probably, I would say, there's the 7406 at U8. So let's get this board out and desolder that pin. A full set of screws. You don't see that very often in a C64. And I want to see what they did on the back of this. Yes. Oh, more stuff was done. Okay, some of this is unexpected. So the CPU, oh yeah, we did think that the CPU was changed. And the PLA was changed as well. The socket was put in the PLA and the CPU and the CIA in U1. Everything else looks factory. That looks all right. This is a trick that I learned from Jim at Happy Little Diodes, who has an excellent YouTube channel where he mostly repairs ZX Spectrums. So if you like my stuff, you'll definitely like his. He's just built himself a swanky new studio workshop as well. So he's really on it. But yeah, go and subscribe to Jim Happy Little Diodes because he's ace. I really like Jim. think I got it on the first go. Hey, you can check on this side, actually, probably a little bit easier. Okay, so this Ferris B down here, FB8, is connected to that wire. But if I check on the top of the leg, I've got nothing there. So I can check here for that signal, see if that's being pulled high or low, FB8. It's doing the same thing, which is fine. And okay, right here is where we're looking for that. That's gone up to 5 volts. It's the CIA. So what happens if I resolder that and I connect a resistor in between that point and 5 volts to pull that up a bit more aggressively to 5 volts? I think that's probably not worth it, but it'd be interesting to see if that would actually overcome that problem and then it would boot. I mean, it's still going to be a problem. Right, I've grabbed a random resistor here. It's a 3K resistor. I'm going to resolder. Hang on, we've got to find out where I've got 5 volts on this, so I can solder something to close by to it. Just to hold that down. Right, don't think anything's going to short out there, but I'll put my Kung Fu flash under here just to keep the pressure off of that side of the board, and then we can see if that will let it boot. No, it's not enough. No difference at all. Okay. Right, let's remove that. Take the CIA out and test it. And it still could be something else because, you know, this is me and my track record at the moment is abysmal. Weirdly, all of the pins have been bent the same way. Usually they'll bend one side out and then the other side out, or both sides in. But they've all been bent out to my right on both sides. And the solder smells on this one. I saw the pins reflowed and straightened. Let's get this out. It's worth checking the other side actually to see if the solder is being removed from the other side, just to make things, you know, sometimes it can look like the solder's gone from this side, but it's still quite a lot on the other side. And that means that your solder gun's all blocked up. That's really clean, really nice board to work on, this one. Yeah, it looks like all of the solder's gone from the other side. Very clean pull so far. I'm going to lift a dozen traces now. I don't normally do this, but I'm going to just give this a tweak on this side to see if I can free up all of the legs, and it might just drop out without even needing hot air. Yeah, it's moving. This is quite rare. Let me show you this side. So that whole side is free. I've got a few that are still stuck on this side, but that should be now doable. My goggles on. Oh no, it's fallen out. What a lovely pull that was. Oh no. Okay, the reason that all of the pins were over one side is not because they've been bent over when they were soldered in. It's because the machine that chops off the ends of the legs after it's been, well, once it's in the board, before it's soldered, I think, has left the little hooks on the end of each leg. Would you like to have a look at that? This is the bane of my life. A very difficult thing to show, but you can see fairly clearly each leg. How am I going to do this? Has a little hook The only way I can really deal with these is to chop them off. Like this. That one's already gone. Quite difficult to do this. Right, that's got all of those legs. I still have all of these ones and they're all on the inside. I don't want to actually cut the leg. I don't want to take any more off than is already missing. Okay, so the reason I don't want these to still be, there's still one there. I don't want these to be hooked is because when I put them in my test board, they'll go in fine into the socket, but they'll rip the socket pins out. That's the best I can do to protect my socket, but it still probably won't be enough. But to be fair, the socket on that test machine needs changing anyway. It's got a bit loose and baggy. Put it in the right way around. But to be fair, this is in U1 now. That might not be right still. That there is a chance because pin 9 on U1 doesn't do as much. Let's have a quick look at the schematic. I don't think not as much directly to the running of the machine. So pin 9 is PA7 again, but it just goes straight out to the keyboard connector and up to the 4066 and U28, which is over here. That's something to do with controllers and things. I think we might still, we've got a flashing cursor, so it is working. This is a good opportunity to learn even more. Let's stick the test harness on this and see if it passes that. Okay. Keyboard bad. And control port bad. 4066 at U28 bad. Yes, that's exactly what I was hoping for. Well, kind of, I was hoping that it would fix itself and then we wouldn't have to waste a CIA on this, but yep, that's what's wrong with this one. Let's leave this bad one in here for now. And see what the other one does. First of all, without a CIA in that socket, I'm just curious. We've got to put a socket in there as well as, before we do anything. Without CIA in that position, and then with a good CIA in there instead. Cool. I'm using cotton buds to clean up here, but Sven Peterson, the marvelous Sven who makes so many wonderful things on. Oh, by the way, I just need to say that the schematic I'm using for this 250407 is off of BWAC's GitHub, and he's reverse engineered the 250407 and has shared the schematics on his GitHub, and it's my go-to schematic. So I really need to give him a shout out. And another really nice person in the community is BWAC. But Sven Peterson told me about using cotton buds to clean up flux. And with all of the SMD rework that I was doing on that Amiga 600 three-parter recently, he pointed out that there's some sponges, like nano sponges that you can get that work better than cotton lint-based cotton buds, which leave bits of fibre all over the place. So I've got those are on the way, Sven. But thank you for the link and the heads up. That's really kind of you. But for now, I need to use these because it's all I've got to hand. Well, I've actually got some Kimtech that repair face Mark sent me. Kimtech wipes, Kim wipes, delicate task wipes. But if you use these on something like this, they end up just getting ripped. Actually, it's not too bad on this bit, but anywhere there's left bits of tissue all through there. It's really annoying to get rid of. But they are the better thing to use than cotton buds, but cotton buds are just convenient. Anyway, right, where is my toothbrush? Just to get rid of that. There we go. Much better. Let's stick a socket in there. Okay, socket is in. I'm just going to put this. There's a lot of debris on my desk, a lot of soldering debris, so I'm just putting it in its case to protect it against shorts. Something I should do really more often, but you move so quick when you're soldering, when you're fixing so many machines. Right, so what does it do without that CIA in at all? We get the same sort of thing with no CIA in there. That actually worries me. That concerns me a bit. Let's put a good CIA in and see if it boots on its own. That concerns me even more. It's not fixed. Okay, let's, I think that diagnostics does run. I'm now thinking that it's the 7406 at U8. Right, that does run, and the normal diagnostics runs as well. Before, actually, one thing I didn't show was that the diagnostics was counting up one of the CIAs wrong. It wasn't counting up the right-hand CIA. Let's put it on no RAM check, it goes faster. Yeah, now both CIAs are counting together. So the CIA was definitely bad. But what is going on now? Why is it not booting? Oh, and just to show you that with a cartridge in, it works. Oh, the SID is bad in this one, by the way, and it's soldered. So let's stick the full harness back on this one. I have checked the RAM. I checked it with Des Test, actually, and it checked. Actually, I'm not sure if the Max version checked. Oh, that shouldn't do that with the color RAM. Test. Maybe the color RAM is bad. I don't know what's going on here. I think I'm going to have a little think about this one and take another run at it. A dark blue screen with no border. Yep, I'm going to go away and have a think. Okay, we're back, and I've been poking and prodding at this computer for a while, trying to work out exactly what I'm trying to do is pin down the problem before I start putting any more chips. It's just better that way. I prefer to do it that way, but as we've seen in previous videos, very recent ones, I'm willing to go the nuclear route if required. Now let's row back and show exactly what's going on with this machine. When I boot it without anything plugged into it, we get this just a normal boot up until it gets to the blue screen, and then it's crashing at that point. If I plug in a cartridge, and this can be a diagnostic cartridge or a game cartridge, doesn't matter, does the same thing with the game cartridge. I get the game works, although the sound is broken because the SID is not working properly, but I don't think the SID is causing any problems. With diagnostics, let's do it with no RAM check because the RAM is checking fine. With the full harness connected, the whole thing passes. There's no problems on this machine at all as far as this can tell. It's even doing the checksums on the ROMs are passing. That is a problem. That's a little conflict there that is causing me difficulties in what to do next, because looking at that blue screen, it looks to me as if the computer is crashing at a certain point, and it looks like the point is when BASIC is activated, when If I take this out, I switch it on now, we get this black screen to start with where the computer is going through reset, and then after reset it starts activating its systems, going through sorry, the different ROMs that it uses. The main ROM is the kernel ROM, which is basically the operating system of the computer, and then it's using the character and the basic ROM to display the text on the screen. So basic is being activated at that point because that's what you're seeing, and the characters are being used to display the text on the screen. So it's one of these three. I think it's one of these three, and I'm leaning towards the basic ROM, but I'm scoping the basic ROM, and you can see it on the scope over here. So this is the chip enable, the output enable pin, which is pin 20. I didn't realize there were two. I'm learning all the time here. And the output enable pin, if I turn it off and then back on again, you do get, if I actually increase the time base, well, which way am I going? This way. Right, so if I turn it off and then turn it back on, there, you see there's a burst of activity, and that's normal, I think. In fact, I've got another C64 here with a probe attached. This is a normal one doing the same thing. Burst of activity. I've just noticed the 555 timer has got a big blob of solder on, but that's a normal reset signal. The reset is working. I think whoever investigated this first before me has done similar things, and what they did was actually desolder, or they cut the pins, the power, the VCC on these two ROMs, the basic and the kernel ROM. They didn't do the character ROM. See, look, that's using characters. That's displaying characters. I can show you that on the working one, that initial activity, and then yeah, look, there are those characters being displayed, and that's basically where it's saying bytes free and everything. The other thing on these is, on this computer, is everything is really, really noisy. There's a lot of noise on there that isn't on the other machine, but that could just be like the electrical characteristics of this computer. It could need new caps or something, but I don't think that's affecting the run time of the computer. What I need to do now is decide what I'm going to do next, and I still don't know. I think it's going to be a case of removing some ROMs, and I need to choose which one to take out next, bearing in mind that two of them have got cut pins. I'm leaning towards the basic ROM. I mean, it's very close between the kernel ROM and the character ROM and the basic ROM. I don't think it's the character ROM. I think that is actually working, and I think that the character ROM is used in the normal diagnostics. In this diagnostics, I think the character ROM is used. I'm going to rule that one out for now, and I'm leaning towards basic ROM. Let's take that one out. The last one I took out, this CIA, practically fell out by itself, so I'm hoping this one is going to do the same. I don't think the desoldering gun was doing quite as good a job as it did last time. There is some movement there. Oh, that pin's gone. That's probably inside. Oh, there, it's here. That pin fell out by itself. Yeah, I think I'm just going to use a bit of heat. I think that's probably the safest thing to do here. It's already moving. Right, so now I've got to put a leg back on this, and they didn't leave a whole lot of exposed leg on the side of this chip. The other thing I could do is actually just pop a socket in here and put a good chip in, because if this is not working, I'm not going to try and rescue it, but I've got plenty of those. So yeah, I'm just going to do it that way around. It's not the way I normally do things. I prefer to test a suspect chip in a good machine rather than a good chip in a suspect machine. This machine is partially working, so it's not too risky, and it's only a ROM. They're easily replaced. Beautiful. What do we think? I reckon 50-50 chance of this working. Come on, baby. Black screen, same problem. Same problem. It's not the VIC-II. The VIC-II wouldn't work if with a cartridge. The VIC-II wouldn't display anything. It's not the VIC-II. It's not the color RAM. Colors are fine when, for the most part, I think. Let's get the kernel ROM out. I'm going to work my way through the ROMs. I can't see anything on the scope comparing these ROMs with known good machines, so this is what we're reduced to at the moment. But I am getting flashbacks from the last video. I'm wondering, is it the reset circuit? Did I see something on the reset circuit that wasn't quite right? Oh, that's I've just sucked that pin through. It's got to be this one. It's not. What the hell is going on there? Is there some trace damage somewhere that I missed? Look, I don't think it is the character ROM, but I am now going to take that out. Only because it's the only custom chip, apart from the SID. I'm going to take the SID out at the same time. That and the SID out, and then I can start investigating what I don't know. This is another one that's mad. How can this be? Thankfully, this is a super easy board to work on, and the chips just fall out by themselves. Right, this time, I say I can check this one in here, but I'm going to have to put the other chips back in here. Right, that should give us a good test. Right, nothing wrong with that character ROM. This is weird. Right, I can put that ROM back in and give it a tick because that one has passed. I'm not going to put these two back in because they're missing a leg. I'll put them in my stores for, you know, a rainy day just in case, but I don't need them. 227 and 226. Let's make sure that we are where we were. Nothing in. Nothing plugged in, just a blue screen. A very, very blue screen. And the diagnostics is now not working. Why is the diagnostics not working? What? My DES test is working. Pretty sure this is DES test max, so it should go into. Oh, of course it is. Totally forgot I had this. Right, so this one. Will do different things. Okay, let's try that one in the broken machine. It's been a while since I've fixed a C64. Sorry, Matt. I'm not very good at remembering things. There could be something wrong with the color RAM with that. I don't know. I'm not sure. I mean, the colour ramp passes these tests, so I don't know. But the image is not perfect. Nothing looks terrible in there. I can't see any red. It's weird, the colours on this. It is displaying all of the colours. Is that still going? Yeah, that's done. Okay, just to rule it out and to put my mind at ease and rest, I'm going to just swap out this VIC-II. Doesn't feel like a very good socket. It is kind of loose in there. Let's give it a good soak of deoxit. I think I'll just stick another one in. 6569R3, 6569R3, nice. Got exactly the right one to go in there. Well, the colours are better. Oh my God. No way. How could that be the VIC-II? No, I'm not having that. Surely it was the socket or something. Oh, how can that? Well, for one thing, I'm glad I checked. It's the VIC-II, which is a huge shame because that almost writes this machine off with a CIA and a SID and the VIC-II. This becomes almost a parts board. I'll probably find a worse condition board than this one and put the parts out of that. So a board is going to, or one of these computers is not going to make it. Well, I've got to know now. Will it work in the other one? Will it work in this one? It's totally the VIC-II. You think you're starting to get a handle on how these things work and how the different parts, especially with the C64, because there are modular parts. There's the display section here, which is for the display. There's the ROM section here that, you know, is the operating system of the computer. There's the CPU and the PLA, which is the logic side of it. The CIAs, which is the interface for everything else on the outside of the computer. And you've got the memory section here, and how all of these different sections link together and how they interact with each other gives you clues when something goes wrong. And if you see a problem with a corrupt display, for instance, or a completely no display at all, you look in the display section. And if it's if it's working with, like, this machine is not working now. I turn it on, there is nothing on the screen apart from that bluey purple colour. But if I put a cartridge in, and it can be DesTest Switch or DesTest Max or a game cartridge, and it works, that tells you that that computer is working, that VIC-II is working. That it's working, look. It's actually a perfect picture. I'm mad as hell. I am mad as hell. No form of logic that I could apply would have led me to suspecting that the VIC-II was bad. The only reason that I checked it was using DesTest Switch. Thank you, Matt Desmond. Had a slightly different display. The colours didn't look right. Those green numbers should be more green, and they weren't quite right. But even that would have led me to the colour RAM rather than the VIC-II. How can that be that? Right, okay. Look, every time that I fix one of these computers, I always want to walk away having learnt something. And it could be argued that that didn't teach me anything, but it did. And that's to not take for granted anything that it could be. Do you know what? I'm not even sure. I'm going to have to absorb this one, and maybe how can I build this into my process going forward when I'm taking another machine? I mean, I'm going to know to check the VIC-II in the future, so it might save me some grief in the future at some point. But today, I am annoyed, and yeah, I'm glad that you have obviously got some entertainment out of this one, but yeah, I'm annoyed. Anyway, time to move on. That's machine number 2 out of this pile of, there's 5 of them, so there's 3 more to do. Well, this isn't it, but this is machine number 2 out of 5 of the normal machines. And once I've educated myself on all the different ways that a C64 could go wrong by fixing these 5, I'm going to move on to the 4 silver labels, the 4 higher serial number silver labels, fix all of those, and then I'm going to culminate this. It's not a series, but there are going to be, well, I'm going to mix in some other computers along the way so we don't get bored of C64s, but it's going to culminate in the low serial number C64 repair, where I've asked for other people's opinions, people on the internet, which is something you should never do. And we're going to fix that C64 together with my swelled up brain full of C64 repair knowledge. I really do hope you enjoyed this one. I did up to a point. But yeah, anyway, thanks for watching. I'll see you in the next one. Bye.